Hi, hello friends, welcome to our channel Study of Mathematics. Hi friends, today we'll discuss the next problems in the exercise 3e section 1. The problem is problem number 2. The problem is if a equal to a plus ib, c plus id minus c plus id, a minus ib, and the given condition is a square plus b square plus c square plus d square equal to 1, then find the inverse of a. This is our given problem. In this problem also we had to find the inverse of a, nothing but a inverse value. For that we had to given a 2 by 2 matrix a, and then also given a one condition. Then we will go to solution. First write down the given matrix. Given matrix is a equal to a plus ib, c plus id minus c plus id, a minus ib. This is a given matrix of order through 2 by 2. First we have to find the inverse of a. First we have to check whether the given matrix is a singular matrix or non-singular matrix. For that we have to find det a. Determination of a is equal to a plus ib into a minus ib minus of c plus id into minus c plus id. That is equal to, here we have to apply the one of the formula is that a plus b into a minus b is nothing but a square minus b square. That is a square minus, here b square means ib square, ib whole square, minus of, here also same formula a plus b into a minus b, but here we have a plus b into minus a plus b. That is nothing but, this is can be written as id minus c. That is the formula. Then first id whole square minus c square, id whole square minus c square, that is equal to a square minus of I square into b square minus of, here also I square into d square minus c square, that is equal to a square minus I square value is nothing but minus 1 into minus plus b square minus of, here also I square value minus 1, then minus d square minus c square, that is equal to a square plus b square, we multiply with the minus into minus plus d square plus c square, that is equal to, here we given a square plus b square plus c square plus d square equal to 1. This is nothing but a square plus b square plus d square plus c square, that is also equal, that is equal to 1. Then det a equal to 1, that is not equal to 0. Therefore det a is not equal to 0. Then a is a non-singular matrix. Non-singular matrix. Then A is invertible. Then the matrix A is invertible. First we have to find the determination of A. Then A is invertible. Next we have to find the adjoint of A. For finding A inverse value, we have to find the adjoint of A. Adjoint of A is nothing but the transpose of a cofactor matrix of the given matrix. Then first we have to find cofactor matrix of the given matrix. Cofactor matrix of the given matrix. Then the cofactor matrix of A is B equal to, let it be B. The cofactor matrix of the given matrix A is B equal to, we know the A minus IB. A minus IB. Cofactor matrix is minus 1 whole power I plus j into minor of the first element. Then minus 1 whole power 1 plus 1 2, that is minus 1 whole square, that value is positive. Then A plus IB minor value is A minus IB. We have to write directly. And then next C plus ID minus 1 whole power first row 1 plus second column 1 plus 2 minus 1 whole cube, that is minus of minor of C plus ID. C plus ID minor value is minus C plus ID. And then similarly minus C plus ID minor value is minus of C plus ID. And A minus IB cofactor value is A plus IB. By using the same procedure we have to already taken. Then B value becomes then the cofactor matrix B equal to A minus IB, minus into minus plus C minus ID. Here minus C minus ID, A plus IB. This is the cofactor matrix of the given matrix. Then we have to find the adjoint of A. Adjoint of A is nothing but the transpose of the cofactor matrix of the given matrix, that is B transpose. B transpose value is A minus IB minus C minus ID, C minus ID, A plus IB. This is the adjoint of A value. Then we have to find A inverse. A inverse equal to, formula is adjoint of A by det A. That equal to 1 by det A value is nothing but 1 into adjoint of A value A minus IB minus C minus ID, C minus ID, A plus IB. Then therefore A inverse equal to A minus IB minus C minus ID, C minus ID, A plus IB. This is the A inverse value. This is the A inverse value. The procedure is same, but one problem has the one theme of solution. Next we have to go the third problem in the same section, same exercise. Then next the third problem is, if A equal to 1 minus 2 3 0 minus 1 4 minus 2 2 1, then find A transpose whole inverse. We have to find the inverse of A transpose of the matrix. Then go to solution. Given matrix is A equal to 1 minus 2 3 0 minus 1 4 minus 2 2 1. This is the given matrix. Next we have to find the transpose, because we have to find the transpose of a given matrix inverse. Then first to find out the transpose. A transpose equal to 1 0 minus 2 minus 2 minus 1 2 3 4 1. This is the transpose of a given matrix. This is the transpose of a given matrix. Then from this onwards the procedure is same. First we have to check whether the A transpose matrix is a singular matrix or non-singular matrix. For finding that we have to procedure same. Then let, for our convenience, B transpose value, let it be B. We have to let For our convenience, let it be B. Then we have to find the B inverse value. Directly we have to find the B inverse. Then determination B. Det B. Det B is nothing but det A dash or det A transpose. Then 1 into minus 1 minus 8 minus 0 into minus 2 minus 6 minus 2 into minus 8 plus 3. That is equal to 1 into minus 9 minus 0 minus 2 into here minus 8 plus 3 minus 5 minus into minus plus 5 into 2 10. That is equal to 1. This is not equal to 0. Then determination of B is not equal to 0. Let B is not equal to 0. B is a non-singular matrix. Non-singular. Then B is invertible. Here B is nothing but A transpose. Here B is nothing but A transpose. Then first we have to find the adjoint of A. For that we have to first find the cofactor matrix of the given matrix. That is cofactor matrix of the, find out the matrix. Then the cofactor matrix of B is, let it C. That equal to, by the procedure of the finding a cofactor matrix, the matrix is minus 9, 8, minus 5, minus 8, 7, minus 4, minus 2, 2, minus 1. This is a cofactor matrix of this matrix. This is not a cofactor matrix of this matrix. This is a cofactor matrix of B. B is nothing but A transpose. The cofactor matrix of the A transpose matrix is C. Then adjoint of B. Adjoint of B is nothing but C transpose. That is equal to minus 9, minus 8, minus 2, 8, 7, 2, minus 5, minus 4, minus 1. This is the adjoint of B. That is adjoint of A transpose. This is nothing but adjoint of A transpose matrix. Next we have to find the B inverse value. B inverse. Next B inverse, that is equal to, the formula is adjoint of B by det B. That is equal to 1 by det B value is 1. 1 by 1 into adjoint of B value minus 9, minus 8, minus 2, 8, 7, 2, minus 5, minus 4, minus 1. Then B inverse equal to minus 9, minus 8, minus 2, 8, 7, 2, minus 5, minus 4, minus 1. Here B inverse is nothing but, B is nothing but A transpose. Then therefore B is nothing but A transpose of inverse. That is equal to minus 9, minus 8, minus 2, 8, 7, 2, minus 5, minus 4, minus 1. This is the solution of the third problem. In this problem, there is no confusion. First given a matrix A and then find the A transpose inverse. We have to find the matrix inverse which has the transpose of a given matrix. Then for that, first we have to find the A transpose. Then let it be B. Then the procedure is same. We have to find the inverse of B. B is nothing but A transpose whole inverse. And thank you for watching. For more videos, please like, share and subscribe to my channel. Thank you. Thanks for watching our video. For more videos, please like, share, subscribe to our channel and hit the bell icon.